Shalom class, my name is Innocent MAPANDA. Thank you for tuning in to Innocent MAPANDA tutorials. Today we are going to attack matrices. I have extracted a question from November 2020 Zimsec paper 2. This is question number 8, section B. We are going to start with part A of the question. It reads, write down the matrices for the following transformations. Number 1, reflection in the y-axis, 1 mark. So to find the matrix for reflection, we can make use of the unity square matrix. So the unity square matrix is a Cartesian plane, which is made up of 1, 1, minus 1, and minus 1. And this is A, and this is B. So A and B, they represent the original points before the transformational process. I hope you are following. Right. So our matrix is going to be made up of A1 and B1, where A1 is going to represent the image of A, and B1 is going to represent the image of B after the reflection. Right. So the reflection is in the line y-axis, meaning to say this y-axis is going to act as our mirror line. I hope you are following. So if y-axis is going to act as our mirror line, it means if we reflect A is going to appear on our left side. So A1 is going to be on minus 1. And this point is minus 1 for x and 0 for y. So you write minus 1 here and 0 in column. I hope you are following. Then, if you clearly notice, you can see that B is lying on the mirror line. A point which is lying on the mirror line becomes an invariant point. It means if the original point lies on the mirror line, the image point is going also to appear on that mirror line. So, B and B1 are going to share the same point, which is invariant, and that point is 0 for x and 1 for y. So you write it in column way, and this is the matrix. So the answer for part A1 is minus 1, 0, 0, and 1. Then you are home and dry. I hope you are following, class. We move on to part A2 of the question. It reads, write down the matrix of a stretch by a factor 5/2 parallel to the x-axis. I have a troubleshooter that I normally use for stretch. If y-axis is invariant line, I use the troubleshooter Q. If x-axis is the invariant line, I use the troubleshooter look. Right. So for Q, the first two letters we have K, 0. The last two letters we have 0, 1. Meaning to say K0 and 0, 1 becomes the matrix for stretch if y-axis is the invariant line. Then for x-axis invariant line, the first two letters it's 1, 0, and the last two letters is 0 and K, and they represent the matrix for stretch if x-axis is the invariant line. I hope you are following. Right. If you hear the statement parallel to the x-axis, parallel to the x-axis is good as y-axis is the invariant line. I hope you are following. So if y-axis is the invariant line, I'm going to use the troubleshooter Q, which is K, 0, right? 0, 1. But remember, the stretch factor was given as 5/2. So my final answer is 5/2, 0. Then 0 and 1. Then you are home and dry. On to part B of the question. It reads, solve the equation, 3 marks. Right. So to solve this equation, you calculate the determinant of the matrix on your left, then equate it to 0. So it is very simple when calculating determinant. What you need to do here, you start by putting a plus in the first on the top row. Then you put minus, then you put a plus, something like this, right? So I'm going to take this plus 1, right, open bracket, right. 1 is going to multiply a 2 by 2 matrix, which is going to be made up of numbers in the second row and in the third row, which are not aligned to this one. So numbers in the second row and third row not aligned to this one, we have y plus 1, y minus 1, 2y, and y plus 1. I hope you are following. Then we move on to this one. There is a negative sign on top of 1, so I'm going to write minus 1. Then I put another bracket. So I'm going to find 4 numbers in the second row and the third row which are not aligned to the middle one in between. We move on to this 1 at the end. You write plus 1, open bracket. What are the 4 numbers not aligned to this one? This is y, y plus 1, y minus 1, and 2y. So I'm going to write equate everything to 0. I hope you are following. So this is the first stage, right? So I'm going to find the determinant of all the 3 brackets, right? And multiply them with the corresponding scalars. I hope you are following, right? So here we are going to multiply the first row first. Y plus 1 times y plus 1, you get y plus 1 squared. I hope you are following, class. Before we multiply the second diagonal, you put a negative sign. So 2y times y minus 1, you get 2y, open bracket, y minus 1. We are done with the first bracket. I hope you are following, class. Then I'm going to put this negative 1 so that I do the multiplication inside a big bracket. I hope you are following, class. The first diagonal is containing y and y plus 1. So if we multiply y and y plus 1, you are going to get y, open bracket, y plus 1. Then you put a negative sign so that you multiply the second diagonal. Y minus 1 times y minus 1, you get y minus 1 squared. Then you close your bracket. I hope you are following. Then you move on to the last one. Since we have a plus 1, there is no need for me to put a big bracket like this, because plus has no effect on the signs inside, as with this negative sign in the middle bracket. Right. So the first diagonal is y times 2y, you get 2y squared. Then you put a negative sign so that you multiply the second diagonal. In the second diagonal, we have y minus 1 times y plus 1, which is difference of 2 squares. So I put open bracket, then I write y squared minus 1, because y squared minus 1 is good as y minus 1, y plus 1. Then equate it to 0. I hope you are following, class. Right. So what is y squared plus, what is y plus 1 squared? You get y squared plus 2y plus 1. Then here you get minus 2y squared plus 2y. I hope you are following. Then let me hold this negative sign, negative 1, so that I finish up the multiplication here inside the big bracket. So y times y, you get y squared. Y times 1, you get y. Then you put negative, then you put open bracket. You get y squared minus 2y plus 1, something like this, plus 2y squared minus y squared. Minus and minus, they give you plus 1. Then you equate it to what? To 0. I hope you are following, class. Right. So y squared, all right, minus 2y squared here is going to cancel out with this 2y squared, since we have a negative 2y squared and a positive 2y squared. Same applies. Y squared is going to cancel out with minus y squared. I hope you are following. So I'm going to be left out with 2y plus 2y. You get 4y. Then here we have 1 plus this 1. You get plus 2. Right. So this 2 was obtained by adding this 1, right, with this 1, so that you get the 2. Right. So I'm going to maintain this -1 so that I simplify the big bracket first before I introduce the -1 inside the big bracket. I hope you are following, right? So we have y squared, right? Plus y here. Then if we remove the smaller bracket inside the big bracket, you get minus y squared plus 2y, right? Since negative and negative you get plus, negative and plus you get negative. So this is -1. Then you close your bracket, equate everything to 0. Something like this. I hope you are following, class, right? So now that we have expanded the terms inside the big bracket, we can now introduce this -1 so that we remove the big bracket. You now have 4y plus 2, right? Minus y squared minus y plus y squared minus 2y plus 1 is equals to 0. I hope you are following, class, right? So minus y squared and y squared, they cancel off each other, right? So what is 4y minus y? 4y minus y, you get 3y, which is going to be less by 2y. Then 2 plus 1, what do you get? 2 plus 1, you get 3. This is equivalent to 0. I hope you are following, class. So 3y minus 2y, you get y, plus 3 is equals to 0. So your final answer is y is equals to -3. This is how you're supposed to solve the equation. So I want you to stay tuned as we move on to part C of the question, whereby we are going to focus on how to attack the inverse of a 3x3 matrix. Right, we are now moving on to part C of the question. It reads, find the inverse of matrix A, right? So I want you to understand something. Inverse of matrix A is going to be found by the formula 1 over determinant times the adjoint of matrix A. I hope you are following. So we have various methods of finding the inverse. There is the Gaussian way, the Gaussian method. We have another method of finding the cofactors. And there is another method that I want you to know of, which is the quickest method of them all. So I want you to pay attention as I go through the stages, so that whenever you see inverse in your exam, you attack it like never before. Right, so the first stage to find inverse is to calculate this determinant. I hope you are following. So likewise, you do the stages that we did in the previous question. Whenever you want to find the determinant, you start by putting plus here, minus here, and plus there. I hope you are following, class, right? So I'm going to write determinant of A, which can be written as A. Then you put these lines, it also represents the determinant of A. I hope you are following. We are going to start with the 2, right? Remember, we have plus 2 here. So I'm going to write 2, then I put open bracket, right? Identify 4 numbers in the second row and third row which are not aligned to that 2. And the 4 numbers is 2, minus 1, 1, and 1. After that, minus on top of -3 is going to multiply this minus to get a plus. So here you write plus 3, something like this. I hope you are following. Then you put open bracket. Identify 4 numbers in the second row and the third row which are not aligned to that 3. We have 3, 1, minus 1, and 1. I hope you are following. Then lastly, we have plus 4. So I'm going to write here plus 4, put open bracket, close bracket. Identify the 4 numbers in the second row and third row which are not aligned to that 4. We have 3, 2, 1, 1. So after that, those scalar numbers which are 2, 3, and 4 are going to be multiplied, right, by the determinant of the matrix in front. I hope you are following, class, right? So what is the determinant of 2 minus 3, 1, and 1? You start by multiplying this first diagonal. 2 times 1, you get 2, you write 2. But before you multiply the second diagonal, you start by putting a negative sign. Do not forget that. 1 times minus 1, you get minus 1. We are done with the first bracket. Then you write plus 3, open bracket. 3 times 1, the first diagonal, you get 3. But before you multiply the second diagonal, you start by putting a negative sign. 1 times minus 1, you get minus 1. I hope you are following. Then you put plus, then you write 4. 3 times 1, you get 3. Before you multiply the second diagonal, put minus. 1 times 2, you get 2. Right? Then you write 2 here. 2 plus 1, you get 3. Plus 3. Then 3 plus 1, you get 4. Plus 4. Then 3 minus 2, you get 1. I hope you are following. So, 2 times 3, it gives you 6. 3 times 4, you get 12. Then 4 times 1, you get 4. So 6 plus 12, you get 18. 18 plus 4, you get a determinant of 22. I hope you are following. Right. So after the determinant, you move to the next stage, which is the transpose of matrix A. So I'm going to write AT. AT, it means the transpose of matrix A. I hope you are following, class. Right. So what is to transpose? To transpose is to convert the columns of the original matrix and turn them into rows. So remember, the first column of matrix A is 2, 3, 1. So 2, 3, 1, the column, is now written as a row like 2, 3, 1. I hope you are following. Then the second column is minus 3, 2, 1. If we transpose it, it becomes a row, which is minus 3, 2, 1. We do the same for the last column. You get 4, minus 1, and 1. So this is the first stage to do. You get a mark for that. We refer to it as the transpose of matrix A. I hope you are following, class. I want you to listen carefully because I want you to attack this in the upcoming exams. Right. Then after that, I want you to rewrite the transpose. There is a troubleshooter for this method that I want you to understand. So you rewrite the transpose here. 3 minus 2, 4. 3, 2, minus 1. Then you write 1, 1, 1. Something like this. Right. So, under this method, you are going to paste and copy the first 2 columns. I hope you are following. So, I'm going to write C1 and C2. The first 2 columns of this transpose of A, we are going to write them under C1 and C2 respectively. So 2 minus 3 and 4 is going to represent C1. I hope you are following, class. Then 3, 2 and minus 1. 3, 2 and minus 1 is going to represent C2. Something like this. Right. So after adding the columns, you need to add the first 2 rows, the first 2 top rows from the top, right, including those columns. So the first row is 2, 3, 1, 2, 3. This is the first row, right? Then the second row is minus 3, 2, 1, minus 3, and 2. So I have just copied the first 2 top rows to represent R1 and R2 respectively. This is the first thing to do. But the troubleshooter is, you start with the columns first, then you end with the rows. So I'm going to put a demarcation line to eliminate the top row as well as the first column. This demarcation line is going to eliminate all the numbers on the top row and all the numbers on the first column. I hope you are following. Right, after that, you find what you call the adjoint of matrix A, which is very easy to identify. So if you start with this 2 by 2, there is a 2 by 2 matrix here. You have 2, 1, minus 1, and 1. We want to find the determinant of 2, 1, minus 1, and 1. I hope you are following. So 2 times 1, what do you get? You get 2. I hope you are following. Then I'm going to write 2. Then I put a negative sign. I hope you are following. Minus 1 times 1, what do you get? You get minus 1. Right? Then you come here. Minus 1 times 1, you get minus 1. Right? Then you put a negative sign so that you multiply the second diagonal. 3 times 1, you get 3. Then you move on to the last 2 by 2 matrix. 3 times 1, you get 3. Then you put a minus. Then 2 times 1, you get 2. So we are done with the first. Right, we move on to the second column. The second column is going to be made up of, we are going to start with 1, minus 3, 1, and 4. So 1 times 4, you get 4. Then you put a minus. 1 times minus 3, you get minus 3. Then you come here. 1 times 2, you get 2. You put a minus. 1 times 4, you get 4. Then you come here. 1 times minus 3, you get minus 3. You put a minus. 1 times 2, you get 2. So you are now left out with the last column to complete your adjoint. I hope you are following. So the last column is going to be made up of the last 2 columns. So I'm going to find the top bracket using the combination of minus 3, 2, 4, and minus 1. So minus 3 times minus 1, you get 3. You put a negative sign so that you multiply 4 and 2 to get 8. Then, to find this bracket, use a combination of 4, minus 3, 2, and 3. So 4 times 2, you get 12. You write 12, then you put a negative sign. 2 times minus 1, you get minus 2. Lastly, 2 times 2, you get 4. You write 4, then you put a minus. Minus 3 times 3, you get minus 9. I hope you are following. So our adjoint is now complete. So the adjoint of A is equals to, remember we have 2 minus minus 1. It gives you 2 plus 1, which is 3. 4 minus minus 3, you get 7. 3 minus 8, you get minus 5. I hope you are following. And minus 1 minus 3, you get minus 4. This is minus 2. This is 14. This is 1. This is minus 5. And this is 13. Then this is your adjoint. Right. So to find the inverse, you write inverse is equals to 1 over determinant times adjoint of the matrix A. So remember the determinant, we found it before in the first stage as 22. So I'm going to write 1 over 22. Then you put open bracket. Then you put this adjoint. 3, 7, minus 5, minus 4, minus 2, 14, 1, minus 5, and 13. And this is your final answer. This is how you find the inverse. Then you are home and dry. Welcome back. We are now moving on to part C2. It reads, hence or otherwise determine the solution of the equations. Then we are given 3 equations. We refer to this as the systems of equations. I hope you are following, class. Right. So I want you to notice something, right? The coefficient of x On the first equation is 2, on the second is 3, and on the third is 1. And the coefficient of y is minus 3, and we have 2, and here we have 1. Then for z, we have 4, minus 1, and 1. Right. If you look clearly, you can see that the coefficients of x, y, and z respectively, they are producing the matrix A. I hope you are following. So to find the values of x, y, and z, it is very simple. What you need to do is, this bracket, if you multiply it with the values of x, y, and z, I hope you are following, you are going to produce 22, 10, and 14. Right. So if you cross over from the left side to the right side, this matrix A becomes the inverse of A, which we found in the previous part. I hope you are following. So in simple terms, what I'm trying to say is x, y, and z are going to be found by multiplying that column vector, or that column matrix, which is 22, 10, and 14, by the inverse that we obtained in the previous part. I hope you are following. So 1 over 22, 3 minus 4 and 1. Then we have 7 here, minus 2 and minus 5. We have minus 5, 14 and 13. That was the inverse. So this inverse is going to multiply 22, 10 and 14, something like this. I hope you are following. So to multiply, you can start by holding the scalar 1 over 22, so that you start by combining the two matrices using the method row by column. So you are going to have 3 brackets here. To find the top bracket, you use top row times the column. So 3 times 22, you get 66. 7 times 10, it gives you plus 70. Minus 5 times 14, you get minus 70. I hope you are following. Then minus 4 times 22, it gives you minus 88. Minus 2 times 10, you get minus 20. I hope you are following. Then 14 times 14, it gives you 196. So you write plus 196. Then you move on to the last row. 1 times 22, you get 22. Minus 5 times 10, you get minus 50. 13 times 14, 182. I hope you are following. So you write 1 over 22 here. You can clearly notice that 70 minus 70, you get a 0. So you'll be left out with the 66. Right? Then minus 88. Right? Minus 20 plus 196, you get 88. Then 22 minus 50 plus 182, it gives you 154. So divide everything by 22. So 22 into 66, you get 3. 22 into 88, you get 4. Then 154 divided by 22, 7. So it clearly means that x is equals to 3, y is equals to 4, and z is equals to 7. Then you are home and dry. So thank you so much for watching. I kindly ask you to invite as many people as possible to subscribe to our YouTube channel, Innocent MAPANDA Tutorials, or you can type Merit Start Center. Please invite as many people as possible so that they can also benefit like what you are doing before the final exams. Till we meet again, Shalom.